this computer. All right. Ladies and gentlemen, thank you very much, and we really appreciate your time. Welcome to the Linux class. This class is going to be fun, easy like yesterday's class, which was really fun and easy, right? Um, there's Today is the 14th of June, 2026. This is module 5. We have 6, 7, 8, 9. I think we have 10 modules all in all. So we're almost at half of critical Linux, and then we are pretty much at the half mark of Linux. So it's sounding like, whoa, that we're going to learn. Have we learned anything big? The way I'm teaching this class is very simple. It's oversimplified, and it's catching all the everything that you need to know. Okay, you won't be able to miss anything. If anybody stops you, like I said from the day one, our commitment was to teach this like if to a 5-year-old. I get comments saying that are we going to learn more? We're going to learn everything. You're going to be certified as a Red Hat certified system admin. So that tells you that you're not only going to learn everything, you're going to learn what it takes to become a certified. And uh, we'll have one class, one weekend on just certification. We're going to put those 22 questions to you. We're going to work through those 22 questions. That is how we know you. We can evaluate you. Then we're going to do an evaluation where we're going to set up the computer. You're going to come in, and you're going to take the mock exam. And when you take the mock exam, that tells us we can certify you as Red Hat certified. So please put in the time of these small bits that we're teaching you. If you fail that exam, doesn't mean anything. It just means you need to go back and take it on your own. We'll open the forum, go practice. The 3 days is all you need, and come back and open the screen. We'll want to watch you take the exam, uh, so that we know that you really know what you're doing. It wouldn't be an open book exam, that's for sure. We can allow that. But if we see that you're kind of falling behind, we may be able to assist you with a couple of mocks with you doing something open book. So this would help you really understand if you really understood the material, right? Because if you can't uh, clear at least, you know, um, 15 to, I would say you need to clear all 21 questions, really. So, uh, no excuse so to be certified. All right. So that being said, keep all that in mind, and don't think, oh, we are not going to read more. Very simple stuff I'm putting because I'm making it simple so it sticks in our mind. History command, right? Everybody has seen the history command. Let's blast off. Let's go. All right, guys. So we have a command called history command, right? A very popular command. Where do we find it? Right? Where do we actually find it? We have part of the hidden files, part of the initialization files. We have a folder called the bash history folder, right? Inside that bash history folder, if you just do hist file size, it's going to tell you how many records, right? You have your oldest record starts from the top, and your recent is always at the bottom, and this starts to fill up on the left. So the maximum records you can have is 1,000. But if you would like to change your records to more, because when you start getting busy and you do not want to lose your work, especially when we will do application, when we do run application files, oh my gosh, that you need all the history, because you'll have to go back and say, oh, how do I start the Docker container again? What do I need to do? Look at Docker Compose. Okay, what did I run here which file did I modify for Python? The main.py file. Okay, so, you know, history file is incredible. And if you want to check history, very simple, exclamation mark, 436. Okay. So can't go wrong. You have the oldest record, the recent record. History is important. Why? Because when you are working in a real environment, you need some history. You're going to be running bunch of commands, large commands. When you start working with SRC files, when we get into Dockers, when we get into Grafana, okay, now you'll be doing some simple stuff. Uh, as simple as this may sound to you, this is the core of all the technology today, right? So you get this, that's a walk in the park as a copy and paste only. This is the core of all that technology you want to learn. History command, know how to use it. Um, I would do you a favor, real quick. Uh, I have a practice lab open. Okay, let me clear that. And you've all seen this. Now, all you have to do is, if you do the up arrow, I can see all the files I've been putting in here. Okay, up arrow, down arrow, up arrow, down arrow. Okay, I can do Control U. I can type in history, and I can see I've got 651 records I've been building in this virtual machine. And I did this because I wanted to show you what the history command can do. So I might find like MD5 sum profile. I wanted to check that. So that's 224. So I can just go down here and just type in exclamation mark 224 if that's still there. Well, I deleted that file, right? That MD5 sum file is not there. Well, I didn't delete that. I'm in the wrong folder. Actually, Etsy, if I run that now MD5 profile, see MD5 profile. So it's going to give me MD5 profile. And if I do the profile underscore back, right, and it's going to give me the sum of that. And if you remember from last time, we are comparing the difference when we take a backup, right? One big part of system admin work is backup, backup, backup. Take a backup before you mess with the file. We're getting into bash scripting introduction next week. How do you open a file? But once we do the file permissions, we pass the file permissions, we have cleared a huge aspect of the Red Hat exam. You have like 5 questions that deal with file permissions. So you knock out 5 questions, that's excellent. You got 5 solid questions out of the way. You can ace that exam, right? So that takes up almost 25% of the exam. So that's why we are on file permissions. Okay, user add and all that. Good. Let me clear this. History command again, guys. We can also look at cd ls-al. We have the history part of the initialization files when we initialize the system. So I can cat the dot bash. Well, we said yesterday you can use a tail command or head command. I can do head, and -n is the number of records I want to see, number of lines I want to see within a file. And let's say I want to see 6, or let's say 10 only, 5. Let's start with 5. Okay, so that is going to be under Etsy dot. Oh, no, no, no. That's under dot. Right. So in case we lost that recording, I'm sure we haven't, but just to keep it consistent, let me go ahead and share my screen and let's get this show on the road. 23 minutes into the whole thing. So we said this is June 14th. We have looked at the history command and we looked at and how to change it and how to get your history. Now, the next thing that we have to do uh, out of this, right, is to understand a key concept that is how the commands are working in Linux. Okay, so when you type pwd on your keyboard, okay, your keyboard is considered a standard in. Okay, so when you type pwd, that's a standard in, meaning you're using the keyboard, it's going to get typed up there, and you'll see a standard out. Okay, so you will see a standard in and you'll see a standard out. I'm not going to share this PowerPoint slides until the next couple hours because I want to be able to clean it up. I've got a lot of good slides that I created last semester. I want to use them with my old ones, which are also very good. So you guys are going to get the combination of best of 1 year of hard work that has gone with our team. So today I'm going to show you practically, right? So PWD and home of Tom. When you type something on your keyboard, you get PWD, right? You type PWD and the machine is going to give you an output. Okay, home of Tom is standard output. So let's look at uh, that impact of PWD, right? So if you type in PWSD, for example, not PWD, but PWSD, your machine is going to tell you something called a standard error, right? The command not found, for example. So there's a standard output of this. There's a problem. Remember that errors are what we are going to chase in the real world, right? The best Linux people are those who can find out the problem and fix the problem from the logs. One of the ways to fix the problem from the logs. We'll show you all the tools you need to do that. So let me not get ahead of myself. So command not found. You type in pwsd. So command not found. Then what happens? So literally, you have three file descriptors for Linux commands and how they work. Standard in, the computer looks at that as a zero, right? A bash in this interpretation of you typing a command is zero. So whatever is coming in from when we do bash scripting, we will do something like we're going to create a very nice file, how to create your own uh, automation script where you can add users, your own automation script, how you're going to manage everything you have done up to now. You will write some simple and nice automation scripts that would help you automate. So anytime you want to create a user, you will hit enter, you'll run the file, and the file will say, give me an input, meaning Bash is going to wait for an input from you. It's going to look at that input coming from your keyboard. So if you type in, uh, for example, the line will say, uh, give me the name of the user you want to add. Okay, we are going to create a little script where we're going to say, so we are going to this. So this is where you're typing your your command, of course, and all of this is part of the standard out. That's all part of the standard out. Sorry, that's your monitor, right? You're seeing it. You're seeing everything on the screen now. Um, this is all part of the monitor, right? So let's say we will have a script, an automation script that we're going to put together. Okay, the script is going to be like, okay, I want to add a user. So there's a the script has something called a read command, right? Its job is to read, meaning it's going to ask a question to you on the line here. Hey, what do you want to do next? Do you want to add a user? You will say, yes, I want to add a user. Input, input the number of the input the name. So let's say you'll put the name Abby. Okay. And so that input you're putting in here is reflecting up here. So it's an input zero on your keyboard. And the output is obviously what you're seeing in front of your eyes. But anytime you get an error, right? So remember that zero is for standard inputs. Um, Not too worried about that. We are largely dealing with one and two. So if you have something coming in, okay, if you type something here, you type whatever you want to type. Oh wow. So this computer is still kind of acting up. Okay, you type something here on your command pwd. Okay, pwd shows up here, pwd on your output. You type pwsd, and you get an output which is an error. You get an error, right? So we're going to see how to manage these errors, right? They're getting printed to your screen. These are errors. These errors are considered as a two. And the two is needed because we need that value to redirect these in the right place. And I'll show you what that means. All right. Nothing to panic. Clear all. Right. So moving forward, let's strengthen this concept and understand it really well. So there are two things happening, okay, known as the input output redirection. So there are two popular redirects used in Linux, and there are other special redirects. When we get down to them, we'll talk about them. But by large, you should know that there's a redirect which is an override, and if you have two of these are called angle brackets. Angle brackets used very much in HTML. If you want to create an HTML header, you have to have this angle. They're called angle brackets. Okay, they look like an angle, right? So when we use this, it overwrites. When we use this, it does append. And let's look at it practically. Okay. So let us create a practice directory, right, as root. So if we create I'm gonna run this lab down with you. So what we're doing in this lab is we're gonna create a directory, right? This is gonna be you guys gonna be working with this on Tuesday. Yesterday the work will be on Monday. Very simple lab. You create a directory called practice lab, right? Um, you create a practice file using touch command. I need to go in here and say you need to be able to go into the practice lab actually test it. Hold on a second. One second. Yeah, you need to CD into that. Okay? CD. You got to CD into that. So this is the stuff I was working on to make it very easy for you all. You wouldn't take away all the heavy lift of thinking. Just follow the lab. So we're going to create a directory. We'll go into the directory, right? We're going to create a file called output.txt file inside that directory, right? So understand what we're doing here. Very simple. We are going to create a directory called practice lab, right? And inside this directory, right, we're going to create an output file, output.txt. Now, in real Linux world, this always exists. We're also going to come and create another file called error.txt, right? Because your company wants to know, hey, give me all the errors you've got. Let's take a look at all the outputs. Okay. Let's understand what the problem is. People don't, the patching happened 10 in the night. Now, the teams that can help you troubleshoot some of these problems, application teams work in the daytime, 8 to 5. That's most people's job is 8 to 5. So the 8 to 5 teams are going to come and look at all these files later on, right? So you want to be able to put all your information into an output file and be able to hand over that file to them so they can start troubleshooting and using it, right? Because that's your job. That's a Linux admin. You're not worried about what that output could be. They just want an output. So you can go to your email and start typing, 100 lines of output. You can take your camera and take a picture of the problems you're seeing, and then go to your email and load it up from your email and send the email to your work email. And from their work email, you're going to copy the PNG file. No, no, sir. That's not how business is done in IT. You're not going to do none of that. You're in isolated environment. You have to work with all the tools, SCP tools. We're going to learn about SCP tools. Okay, how do you transfer files from Linux into Windows? But let's get going and understand our business first. Okay, how to do business with Linux. Now, so I'm going to create a directory, right? And then I'm going to create a file. Okay, it's very simple. So that's what I'm doing here. I go into the directory, right? And I'm going to touch and create a file. This should be all piece of cake. I'm going to look in that file. Cat means view, right? I'm going to be able to view my file. Cat means view, right? You're not changing anything. You're just viewing inside. You're looking inside the file, just like in Microsoft Word, just like this in front of you. This presentation, you're viewing it. Can any of you change anything in it right now? Nope. It's only readable, read only. All of you can just look at it as read only. Cat is like read only, right? You're catting now. You're catting my screen. You're looking at what's inside my files. Okay, I'm sharing them with you. So that's cat. Cat command is running, but this is Windows, right? Windows is giving I'm sharing my screen and everybody's seeing it, but nobody can make any changes to it unless I make changes. So I have full permissions on this file of mine. View. We're coming to that. That's why I'm bringing that word up, permissions. So now you have an output file. So let's try to add information to the output text file, right? Now let's do that. Let's do that. Hold on a second. And let's hold on a second. Let me come back here. Share your screen. Okay. Uh, Still okay. Perfect. Okay. Let's share my screen. All right. So all you guys have to do is open your guacamole or your practice lab, and I can do this with the CMD command because I'm sitting in the data center. Um, what is this? Oh,
Hello, what is sir? Hello, sir.
yes,
Sir, my own practice lab is not open but the Grommet is open. The Grandmole is open.
guacamole is all running, right?
Yes, it's running, but
It,
the lab practice is not running.
oh, oh, really? Okay, well, that's, let me just like take a quick look at it. Lab at nit.academy. Uh, it should be fine. It's working here. Okay. Let me see. Anybody else having this problem with labs?
It's running
Yeah.
for me.
Mine is running.
Yeah, I think you know what? This is a very good problem that he brought up, right? This problem is a ticket problem, right? He says that he's unable to see this, but he's unable to see the other one. He's able to see the other one, and probably what it is the is a if you look at this, there's a timeout on these websites. When we study networking coming up in 2 weeks, we're going to look at the session layer. Okay, a session layer. We have 7 layers in the OSO in the network layers, and one of the layers is application, okay, presentation, and then you have session, right? So this basically you are in a 7-story building, and in that 7-story building, each floor handles a different task. And what is happening is probably where he's sitting down, his internet speed is so slow that the session is timing out for him. As for other people, the connection is happening. This is a user experience problem, and it's a real problem that he's experiencing. Okay. And so even though everything is running, but he's not able to open it. So this is the kind of stuff we are coming to. That's why we created all of this nice stuff for all of you, because we are going to show you practically in companies how these problems come up and how they're resolved, and how the 7 layers are working behind when you open the hood and you look inside it, you'll really appreciate what networking is. Okay. And you'll really enjoy it. All right. Let me close that one. So please take a look at, try it again. If not, try guacamole. If guacamole is working, then you're good. Okay. All right. So let us go here and patiently take time. Like I said, the Urdu classes are not happening today or Saturday. They'll happen on Monday for them. So no rush for all of you. Sunday morning, we're only 38 minutes into the class. It looks like we've been here for 38 hours, but let's try to uh, take some break in 20 minutes. Easy stuff, and absorb it, please. Absorb it. You don't have to come back and watch these videos. Do that if you have to. But if you're following along a little bit, kind of getting this understanding, I am now going into my one. Oh, wait a second. Okay, let's put this 192.168.1.97. I'm just didn't do that. Okay, where's my numlock? This is working. Okay, now it is. Now I could do this on a desktop, but I don't want to do this on a desktop. SSH root. Okay, Control C. That didn't work. Okay, why didn't SSH work? Oh, okay, hold on. You know what?
I think
Uh,
it's 168. You type 162.
oh, okay. Thank you very much, sir. Thank you very much. I'm also having a lot of problem with my keyboard, believe it or not. I would like to use a powerful desktop, but then I'm moving around all the time, so I don't want to do that. Thank you very much. So ABC. Okay. Now I'm in my lab, and I would recommend that if you look inside your lab, LS, okay, LL, okay. Let me remove. Um, Let me remove RF. Let me remove commands. ls.txt, output.txt, practice. Okay, let's see that because that's a directory. Commands, it's not going to work on commands. Commands, RM does not work on that. It's only for files. So let me remove that. Okay, remove regular empty file. Yes. Yes. Okay, LL. So if you guys want to do some cleanup, it's a good time to practice your ls command or ll command and then rm-rf commands. Practice. I think we can only do one at a time. Yep, we can only do one at a time. Rel 9 does not allow multiple. Right. Okay. So now we can. You guys can go into where am I now? I am at home, my own home, the home of root. Okay, and I'm going to go ahead and make a directory, -p, and the name of that directory is practice lab. If I look at it, I have a practice lab. I'm going to cd into practice lab. Note I'm using relative command. I don't need the / because I'm already sitting inside practice lab. I'm sitting in my home and I'm creating everything in my home. I don't need to define a path from / all the way. I keep bringing this up because people are probably still trying to wonder why don't I try this? Okay, CD. If I try this, will I be able to get into practice lab? No, because now you're saying under this absolute path, there is something called practice lab. And the truth is, if I look at that, I don't have any practice lab under there. So if I enter that and I do ls, I don't have any practice lab under this directory. So you can see this is I'm root. Okay, this is the name of my VM. This is the directory I am in at the moment. This is where I am in. I'm sitting inside this room called root directory. What do I see in my room? If you change your room to your bedroom, you change the room to the kitchen, or you change the room to your dining room, are you going to see the same things? Absolutely not. I'm sitting in, I'm at the door. I'm viewing everything in my house. Okay, I can see there's all this stuff. But now I want to go into this root. Okay, the home, a directory named root, which is the home of the user root. So I'm going to go into that root. I can do it this way, and that will work. Or I can do it this way, and that will work. And guess what? Rel has made it so easy now. Just do CD, and I've switched. I'm now in home. I've gone into this place. Okay. Now, when I am sitting inside my own home, what do I see? Let's see what I can see inside this. This is my home. The name of my home is root. If I told you you're coming from the airport, say, Nadeem, where can I find you? Root. Oh, where can I find you? Root. No, no, where can I find you? Well, for God's sake, the name of my house is root. The address is called root. So, oh, I see. Okay. So come to my house. So I want to come to, is my house called media? No. Is my house called home? No. Where is my house as a root user? Root. Come to my home. It's called root. So where am I now? I've changed my directory. I'm in home. I'm in root. Okay. So many ways I can be root. I can do CD root. I could do CD tilde, and that's still the same. See, same thing, same thing. How do I know where I am? PWD. I'm sitting in my home called root. Okay. Inside this home, inside the home, I want to see everything. You open your door. Are you blind? Yes, you are. At the moment, you are. I don't see anything. Do you? I don't see. You don't see. How can I put my glasses on? ls-l. This will help me to view. I can view, see, get an idea of look around your house. What do you got? So now I got a bunch of things. Aha, we're going to use this Anaconda. We're going to talk about it later on. Just don't worry about it right now. The user in a 90 this with this IP, they have this. I went ahead and created a practice lab. Now I want to go inside the practice lab. If I'm already inside the house, I don't need to go back out and then open the door and walk to my room. I'm already inside. So I don't need to say CD, let's go outside the house. No, I'm inside the house. Where am I inside? I'm inside my home. And if I want to go within the house to a room called practice lab, okay? Practice lab. So practice lab. Okay, and let me do one more thing here. Let me make a MKDIR. Okay, let's just do an MKDIR called dining room. MKDIR kitchen.
Sorry, Nadim, just
Yes,
1 minute, please. I can see you use mkdir-p and mkdir without the dash p, and you're
yeah,
getting the same result. Because I did the same. The first one I did was mkdir without dash p. I got a practice lab. I
right.
now felt, okay, why is it that without the
Very good.
dash p, I'm still getting the same results?
Yes, thank you very much. And this is your very good. This is your what do you call this thing? Uh, TV room, your lounge. Okay. Now, for all uh, uh, practical purposes, uh, and I'll come back to your question. When you do MKDIR -P, and the reason we do -P is because down the line in practically in a enterprise environment. So enterprise environment versus test environment. Okay. So the when you're in your test environment, which is what we are in right now, I want to do a test environment. I'm not going to put anything in the dining room, even though that's going to work. If I know that my directory is just a test directory, uh, 1 second. जी खान खान साहब अस्सलाम जी 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 ठीक है जजाकल्ला ठीक है जजाकल्ला थैंक यू राइट so let me first show you this and I'll come to that answer that question for you now. um, so if I am somewhere in the system, okay, and I want to go home, I can just go to my home. I clear this and I see I'm inside the house. So if I am inside the house, I can see a bunch of things. I can see my dining room, I can see my kitchen, I can see my lounge. I'll finish that, Abby, and I'll come back to you. I'll tell you what that is. Okay. So if I am now going into the dining room, do I do CD/dining? Will that work? No, because I'm already inside my space. You only use this when you have to go to root and then you have to go to dining. Okay. But because I'm already sitting inside here, I don't need to put if I use this /dining, because I'm already here. So if I minus this, I'm already sitting right here. Now, if I do it this way, this is even a wrong statement, because this means you're going to locate yourself from the top of the root directory. And we know that in the root directory, there is no such directory called dining at all. So you have to remove this dining. Then you can be in dining. If you go CD again, and we go into CD kitchen, is basically you have closed the door behind you now. You're going to the kitchen. You'll be at the kitchen. Go back out of the kitchen. Where do you want to go? I want to go to the lounge. So now I'm in the lounge. Okay. So uh, before I go forward, I want everybody to understand this absolute and relative path. You know, Does everybody understand this? Does
Yes.
everybody
Yes, sir.
understand?
Yes.
Yes, sir.
Right. Perfect.
Yes.
Okay. If we are clear, then okay. Now let's clear that out and let's go cd dot ll and rm hyphen rf, or just remove for now kitchen, lounge. Oh, this is directories. So they're empty directories. So I can just remove lounge. Let's try. We'll take 2 directories at a time. Yep, it did. Okay, the empty directories, kitchen and then room and dining. Right. Okay. So the question about mkdir minus p in the enterprise level, what it does is it prevents mistakes and problems. By giving it the p, what you're saying is that if I'm creating a directory called let's say logs, okay, .txt, or I'm looking at HTML underscore logs .txt. What this is telling us is that, sorry, a directory. We're talking about directories. We are creating a logs directory, not file, logs. Okay. Now, if we are creating a mkdir-p logs, and if later on we need to go and create under logs another directory, a lot of times it's going to throw an error. So let's say I created mkdir logs, okay, and I want to now create mkdir logs under logs. Okay, it's empty right now. We don't have a problem. At the moment, it's empty, and we're going to look at Apache .txt file. Okay, no issues at all. You are able to create this. But a lot of times in enterprise, because the logs have been there, people are moving and changing the files, you wouldn't be able to create this Apache.txt, right? And that's why the good practice is to go ahead and just go ahead and use -p. Now, if you look at Google Find, right? What is Google telling us? Okay, says it creates missing intermediate path name directory. If the -p flag is not specified, the parent directory of each newly created directory must already exist, where the -m mode represents any option supplied. Okay, all this stuff they're talking about in very simple English, what they're trying to say is you do not want to have errors in your file. Okay, what you want to do? Let me see 1 second. Let me see if we can. Let me see this. 1 second. I'll let me see if I can simulate this.
So in general, for best practice purpose, it's better to use -p to be on the safe side.
Yes, yes. Versus 1 second. 1 second. Let's see if we can. I can generate an error in a file and we can pick it up. Okay. Let's look at this. Let's look at this one. Hold on, let me grab this thing. So let's make a directory called projects. Okay, and we'll say 2026, 2026, and under 2026 we have June, and we created the project. Okay. Now, what do you see? Cannot create directory projects, no such file or directory. So what happened, right? What happened is mkdir is trying to look for projects 2026. So it could place the June folder inside it, right? It's trying to put the June folder inside 2026. We know that mkdir, so because projects doesn't exist yet, we know that. So the system has panicked and failed immediately. So to do this without -p, you would have to run 3 separate commands, right? You would have to run mkdir projects. Then you have to go and CD into projects, right? And then you have to go create MKDIR 2026.
26. Okay, 2026. Yeah.
Yeah. And then you have to CD into 2026.
Yeah, for June.
And then, yeah, you're going to MKDIR June.
June. Yeah.
Now, if we do CD dot dot and we do LL, CD, and then we clear that and we do LL. So now we can go into, I think PS3, what other command? 3-D projects, right? So we can look at the tree -D of the projects, and we have got that in there. Okay. Now, if we do MKDIR projects and we do 2026 and I say July, no problem.
I have a question.
Yes, sir.
My question is this. Okay, now you created MKDIR projects. Assuming you wanted to type projects, then the spelling was wrong. So how do you correct after you already created the?
Very good, very good, very good. Thank you. Let's say that we created an MKDIR. Okay. So this is a very good question. Number one question was very good. This next, so Abby and everybody, you can see that with MKDIR -P, the value of -P is that you can have nested directories in there, right? Sometimes if you have when we do applications, you will have core files there. You'll go project, we will do MKDIR, OPT, we'll go var, we'll create a folder var, then we'll create a file guacamole, and we'll create a directory under the guacamole called css.txt, and under CSS, and then in the CSS, we may have a Docker compose file, in here. So when you're going in applications, you're gonna run into that problem, right? To do such a thing, it's gonna tell you can't do that. But with a -P, it basically connects all the when we do recursively, it's the -P helps you delete them, remove them, change them, put the permissions on them, modify in between permissions on them, because you can change the permissions of this, you can change the permission of only this, you can change the permission only of that, because you may have a permission for everybody to go into guacamole, and only root can execute that. We're going to see that. So if you don't have the -P, you don't have that nested correctly. It's a safety net. So, but in our practice purposes, for test purposes, we are fine. Okay. Answering the question from Mr. Wolex, that we have practice lab. I want to change the name of practice lab. Okay. So if I do MV or if I do CP, okay, MV practice lab. There you go. LL, sorry. Oh my God. Okay. We have practice lab. Okay. I want to change the practice lab back to practice lab with no dash. So I'll just use the move command, practice dash lab, and I can rename the file as practice lab. Okay. So now I can see my name has changed. I can also use this copy command, cp-r, practice lab, and I can give it any name I want, practice dash lab. Now, if I do the MD5 sum of practice lab and I do the MD. Oh, well, no, not directory. This is a, what is it? MD. What do we have here? Okay, we have, what files do we have here? So we have practice lab, we have practice dash lab, and we removed the practice. Okay, we have practice lab. There you go. So you have two ways to do it. So if you want to initially just rename it, and you don't want to, you're worried that you may lose the data or something, just copy it, and copy will do the same thing. But if you're 100% sure you want to, you can remove RM, RMDIR, practice dash lab. And if I look at it again, that's gone. So I only have the practice lab. So we have the practice lab. So that's how you change the name on it. So let's move on. Let's move on. Let's look at the lab that we want to do here. So we can look at redirects. Okay, so we have clearly, I can see the tree -D of my practice lab. Well, there's nothing under the tree. So that means I haven't created anything. So in our exercise, what I'm saying here, okay, let's switch over, right. What I'm saying is that we have created a practice lab. We have gone into the practice lab. Let's create an output file. So let's create an output file. So if you look here, I don't have any output file. So I'm going to use the touch command, and I'm going to use the output.txt. So if I check again, ls-l, you can see that we have output.txt, right? So with that being said, now that we have an output file, let's try the next thing. What's the next thing it says in this? And I'll send this file to you guys after this class. So what I have put in there says, okay, I want to use the redirect. Remember this, we said that this is an override, this is an append. So this is redirect, which means that I would like to type something on my line command, system logs, okay? And I would like to go and dump them or put them or add them to my output file, output.txt. Now, remember that this is the command line. There is no command known as system logs. So will this put it inside the output file? Let's check it out. Let's do something. Let's clear our screen. So if I said system logs, this is the word. Let's say this text you a bunch of things you want to put inside a file. You're going to redirect it, right? You want to redirect it, angle bracket, into the output.txt. System logs command is not found. We know that. Now, if I typed echo and I bind this under the string, consider this as a string. Now let's check the output file first. Let's cat the output file. There's nothing there. Okay. So we just want to go and do echo system logs, and we're going to redirect that. I'm going to redirect it. Sorry, I'm going to redirect that into the output.txt. What am I trying to do? I'm trying to take this word, and the Red Hat exam, we will use this echo command a lot. We're going to use this also in our lab in learning how you can change your passwords without typing password and then say, do you want to change the password? Old password, new password. This is a very powerful command, echo. We're going to use this in scripting. We're going to use this in putting our outputs. So we have started using this early on in the project. So system logs, it's going to take that exact word, right? And it's going to put it inside this file. Let's do that. So hit enter. Okay. Remember, we created the file using the touch command. So let's cat this. Cat. You can see the word is there. Now you can add anything else you want. You can add things like equal system logs equal, hit enter, and you can cat your thing again. There you go. Right? So it has done something. Before I had the word system logs, when I went ahead and did use the angle bracket, it did an override. It deleted this and it replaced it with this. Okay. So that's what this command will do. So it is not recommended to use this command a lot unless you are doing this in a practice lab or test lab or you're testing some things out. But if you have a big file which has a lot of information, and if by mistake all you wanted to do, like for example, when we did wanted to add something to a profile file, remember that we had a problem because if you only use one, it's going to wipe out, delete everything in that file. It will literally delete everything and it'll replace it whatever you're putting in there. So let's look at our lab again. Okay. So it says when you do this, you're going to get an output. Okay. But when you do ecosystem, you'll be fine. Now look at practice redirect number 2. Okay. Let's say you want to redirect the output of a command, ls-l. Okay. Output.txt. What it's going to do, it's going to override everything that is system logs, and it has whatever the output of ls-l is. When you type this, whatever the output of ls-l is, it is putting that in this file for you. So I'm teaching you how down the line, if you wanted to take any output or you want to run a command and see and share that with your team, what you were seeing at 10 p.m. in the night or what you're seeing at 11 in the morning, and you want to share those files with people, you can create yourself a nice output file. You can run a command, redirect the output, dump the output inside. It's literally like a dump. You're dumping anything this thing will do. Let's try the date command. Let's try the date command. What will the date command do on output.txt? Okay, let's cat the output file again. It has removed all the previous information, replaced it just with the date. You want to uptime information that you want to
But
send.
Nadeem sir, you are doing this without the echo.
No, so
Before this, we have used the echo command, but now you are doing this without the echo.
Very good question. Third question, a very good question coming. Let me explain that again, why I did that example. Now, if ls-l, Linux recognizes ls, right? ls ko pehchanta hai ye. Does Linux recognize Nigeria?
No.
No. If I try to send Nigeria, the word Nigeria into output.txt, it says command not found. It's looking for a command on this line first. Nigeria is not a command. Asim / output.txt. No. But does Linux recognize echo? Yes. Linux has a command called echo. It says, where is echo? Echo is in a path called user bin, and you will find it. There's a command called echo. There's a manual for echo to read much on echo. You can do a manual on echo. Echo display a line of text. And we have a bunch of flags. We're not going to waste our time on these flags. Okay. You can spend a lifetime mastering these flags. You don't need that. You just need the echo command. So I'll quit. I'm out. So it's saying, hey, echo has a path. But where is Nigeria? No, sir. Unless you want to define you want to create your own command called Nigeria, you can get it. Does that make sense? So you wanted to say Pakistan.
Yes,
Pakistan is not a command. So we can only take those commands. And how do we know which command works? We have to use where is, PWD. Where is? echo, where is ls, where is date, where is uptime? There you go, simple and short. So, but Nigeria, no. Now, let's cat the output.txt file. If I want to put Nigeria in there, in that file, I have to use echo because Linux should recognize this. And echo requires you, the syntax for echo is open your bracket and put Nigeria in between. Okay? Sorry. Cat output.txt. There you go. Nigeria is in your, but as long as you have that in a string. But let's now do something else.
Nadeem, I
Let's
have a
do,
question.
yeah, go ahead.
So if there's an error, it would not go inside the output.txt file.
We are coming to that. Hang on. Okay, hang on a minute. So we are coming to that. One thing at a time. Let's look at what can go, and then let's look at what cannot go. But let's try to be clear on what can go, make it into the file, and then we'll worry about what will not go. It's coming up. It's coming up. So date, uptime. Uptime is a command. When you execute the command, what is the output? This is the output. I want this output in a file. Uptime, put this in a file using a redirect output.txt. Date is a command. I want the output in a file. Date slash output.txt. Okay, are we good? Are we very good? Well, you guys will
Yes,
have
good, but
Yes, very much clear. Yes.
it,
Okay.
it keeps overwriting. Is there a way to continually keep
very good.
new
Thank you.
items
That's
in that?
the double
That's
sign.
that's it. I love that. That's it. So how do we prevent that override? Okay, this is where we go append. Okay, now we can use a command which is we are redirecting and appending the new information. So let's append all of this information one more time. So how do I clear the contents of a file? Your manager says to you, delete that you've got a file. Okay, you've got a file called you guys are going to create a file in Python, very important file, main.py. Okay, so let's say that you have to echo, uh, you know, uh, let's say you have to echo a lot of things in that file. That file contained a lot of stuff. Okay, and let's. जी खालिद खान साहब ठीक है जज़ाकल्लाह. So let's say that your main.py file contains this information, right? Okay, this is the output.txt, and your manager says we want to delete everything that's in this file. So first thing you do is you come and cat output.txt, and you say, oh, okay, there's a bunch of stuff. Now, there's a very easy way to clear anything inside the file. All you have to do is echo, open apostrophe, close apostrophes, double, forward that into output.txt. If you cat your output.txt, you see it's empty. There's nothing there. Now, we do have something there. It's just your two little things giving you a blank space, which is fine. Because when we start doing bash scripting, we're going to talk a little bit more about this. So don't worry about that right now. It's a bit ahead of the game. So what we want to do now is we want to take ls-l okay? And we want to go ahead and add it to the output file. We know it's empty, txt. Okay, cat output.txt. Now I want to add date to this file. If I do double into the output file and I do the cat command, you'll see that the date command is here in the bottom. You have all the ls-l, and now you have this as well. Now let's clear that. So I can do date, I have uptime, and I can do output.txt. I can do pwd into output.txt. I can echo and you can see that ls-l, date, uptime, pwd, and echo. Everything is contained in this file. So this is an append, and I can go and say what do you think that would do?
It overwrite everything.
Item and I'll put file deleted on 12th June.
Thank you. Thank you very much, gentlemen, for your response. And that's exactly what I'll do. Perfect. And so we have reached almost an hour. Let's do one more thing and then we can take a break. Okay, let's do the standard errors. Right. So somebody had asked about the standard errors. What is the standard errors? Okay. So let us do something practical. Let's go ahead and change it to a normal user. Okay. We're going to change it to a normal user. Our practical lab says, let's look at our
सर एक
users.
क्वेश्चन है
जी पूछिए.
सर क्वेश्चन ये है कि ये जो छोटी छोटी चीजें हैं जिनको जैसे डेट अप टाइम ये तो लिनक्स जानता है तो वो उसके अंदर कर देगा कॉपी अगर बिल
जी.
फर्स्ट एक फाइल का डाटा आपने इसमें कॉपी करना हो
जी हम जब बैश स्क्रिप्टिंग पढ़ेंगे उसमें हम सारी चीजें पढ़ेंगे इसके बारे में, फाइल के बारे में.
अच्छा ठीक है
बेफिक्र रहिए. Yeah. So the question the lady has is that we are just doing single line commands, we're putting outputs. What about if there's like a big text that we want to dump in there? Right now we can only put one line at a time. And yes, echo can do one line at a time. And it's an important command. When we learn about bash scripting, when we look at how to open a file, how to write our first automation program, how do we use echo to take a large file and just paste it, dump it inside, we will study it at that point in time. But we want to introduce you to the simple output first, and then we'll build on this. So that's the whole. आप पहले ये समझ लेंगे ना तो ये आसानी हो जाएगी अगली चीज को समझने में. करना भी कुछ नहीं होगा ज्यादा. You won't have to do much.
Thank you.
You're welcome.
Thank you.
You're welcome. So let's go into now I have a question for everybody. Okay. I have a question for everybody at this point in time in this lab. Who is, okay, and I know it might be hard to answer, but what is the difference between, so I want to become a normal user. Right now I'm root. Okay, we are going to test out this standard out, standard in at the moment. I'm a root user. I could use su-user, or I can just say su user. What is the difference? Anybody want to attempt it? If not,
Yeah.
Go ahead.
The difference is when you use su minus user, you'll be asked for password to switch between your current directory to the new user.
Very
But
good.
if you use SU without the minus, you will not be prompted for a password.
Thank
Can
you.
I, sir?
Thank you. Yes, go ahead.
When we do SU, actually, the system initialize from this. He read the profile, and he all this is profile is there. He read it and he apply on the when he log in as a SU and user. But if you do the SU, he not read this profile. He just switch the user and the use whatever the user is there. He actually still have the is in his profile, not this new
Very good.
user. He just switch.
Very, very good. Both answers are brilliant. And the when you say SU, okay, and you put the hyphen and we're going to do Tom, okay, watch this, watch the prompt. So you're going to get a prompt in which this thing, what it's going to do is going to it's going to start with Tom, okay, at, right, uh, the VM he's got, practice lab, okay, and we'll see this output. If you type in SU and Tom, what it's going to do is it's not going to load Tom's environment. It's not going to load his profile. It's going to continue using the root's profile. So a root user, we are now root, and okay, under root we are testing this. In reality, Tom has to sign on as when he signs on as SU-Tom, right? So what Saeed said is 100% right, okay? And we're going to fine tune that SU-Tom versus SU-Tom, okay? Let's test it out here in front of everybody. And the answer is that the hyphen here has to do with the initialization files. It's the files that are loaded for Tom. So if you do hyphen Tom, hyphen, it's going to go to Tom. Okay. And sometimes it will ask you for the password. That's why we say this applies with the password. Okay. And to answer, so here's the table. Okay. Here's the table. Let's make it very clear. So SU hyphen versus SU. Okay. And then you have the user. The SU hyphen, it's going to load load the user's profile. User profile gets loaded. Okay. What else gets loaded? Because the user profile is getting loaded, so is the password. So password becomes a requirement. So these two things happen because you are loading the environment. Now, a lot of times in Linux, you're going to notice it's not going to ask us the password. Okay. So don't worry about that at the moment because we are really using a non-enterprise approach. We don't have any hardenings of sudo rights. when we look at the configuration files, right? We can harden this practice that every time the user goes in with SU hyphen, their profile will be loaded and the password is required. When you do SU, no profile will be loaded. It will still be the root's profile, meaning whatever profile root has, root profile is loaded. Okay, no password is needed because root is basically taking over this account for by themselves. So root is taking over the account, assuming the place of Tom, okay, or the user. So it has no password, it has no profile other than root's own profile. Root's profile is working. It's like you are the EFCC. You have taken over. Your profile is now going to be running. Okay, so this is kind of like the let's look at it now. No, let me hold on.
Can you say the SU without hyphen is a partial switch, while the one with hyphen is a complete switch?
Yeah, exactly. So let's look at this. So I am now where? I'm root. I'm going to switch. Okay, switch to the user and make sure you give me all his environment. Remove my environment. I don't want to be in my own environment. I don't want to be in my path. I want to be I want to be 100% Tom. I want to log in 100% as Tom. How do I do that? SU 100%, meaning load Tom's environment, don't load my environment, which is now Tom. Right? You see, when we were studying the profile, I'd never removed that. It has reinitialized it and it has confirmed that the etc profile, we added this in the global file when I was teaching this. I haven't removed it. And this is the proof to say that the profile initialization file ran again. So it ran again, okay, but a password is not required. Even though a password is required, because it is still in root's environment, it's saying fine. You can log in. I've logged in and logged out. Okay. We haven't hardened the password requirement yet. We haven't said you must give me the password. I'm root. I can just get in there without the password. Okay. In this case. Now, if I exit, okay, and I want to log in as root working in Tom's environment, in working in Tom's machine, shell, not machine. So I want to log in as root and I want to work in Tom's shell. The shell is still going to be taking my root. Let's take a look at that. So if I do SU Tom, look at the word at the end, root. That's saying that the environment is root. You didn't see the etc profile. It did not really initialize. You're not really Tom. You are root. You have entered Tom's. You have taken over Tom's machine, and you're going to work in his machine as a root with your own privileges at the moment. Okay, so let's exit that. Okay, and let's do this lab as Tom. 100% as Tom means 100% Tom. Okay, so now I am Tom. I'm not root. Okay, now when I'm Tom, what is the lab telling us?
Sorry,
Yeah,
but
go
it's, I can see the tilde there. That's
Right,
saying that
VWD.
it's still root. Yeah, I've practiced lab tilde. You know, previously it was a practice lab root. They were saying
Right.
practice tilde.
No,
Is it not the same thing?
yes. So okay, let's exit. Let's see. So if we do PWD, okay, it is root as at practice lab. Remember, the machine is the same. The machine we are working on, we have renamed it as practice lab. So Tom will also see the same machine name. If we call it dev, system, what do you call this thing? Host name. Set this host name to dev. Okay. So let's reinitialize the shell. Now it is dev. So now I've renamed so any user coming into this environment will be looking at that as a dev machine. So if I do SU Tom will still see that the machine is the same. We are in the same Linux machine. The virtual machine is the same. So the name of that machine is dev. No matter who enters this machine, it's dev. So can he change the name? Okay. So let's do one couple of things. PWD root. SU Tom PWD is now in his home. Now can he change host name? CTL set host name back to practice lab. But if he has a root password, he can do it. I'm going to put ABC. authentication complete. Did everybody see that? Right? Tom as a user, remember if he doesn't have the root's password, he has no rights. But because I know the password, and Tom is a system admin, he may have the sudo files, but we haven't gone to sudo files yet. We haven't got to that part of user management. We have done a part of user management. We're going to do permissions, and then we're going to get into files and permissions and the special files. Okay, so let's clear that. Abby, still go ahead and ask your question if you're still clear or unclear what we did.
Yeah, it's okay. It's okay.
Okay, so that's what we have done. Okay, so we have changed that. I can exit and exact bash. Okay.
What is the password?
Yeah, so I will. So let's do our lab or stand it out, and we'll come back to take any questions after this. So let's finish this lab and then take a break for 10 minutes. So what we are trying to do is we're going to log in as our first quiz. What is the difference between SU and user, right? Then we said we came in as Tom. Now let's run this command. Okay, let's run this command. Okay. Okay. So let me log in as Tom, 100% Tom. I'm verifying that this is Tom. That's why I left that file to show me. Now what I like to do as Tom is to check. Now Tom, hold on. So let me show you two things here. Exit. If I do tail -n and I want to look at etc password, and I look at etc shadow, I'm root. Root can see the etc password file and the shadow file. Enter. So it says, okay, root can see these two records from the password file. Root can see these two records from the encrypted file. Do you think user Tom can see this shadow file? Let's find out. So if I become Tom and so tail -n, he does the same command that root is running, apples to apples, same command root was running. Now Tom is going to run the same command, etc shadow. So is saying that Tom as a user can go into the etc password file, he can see the users available. But Tom does not have any permissions. He's been denied permission to see what's inside the password, right? Because a normal user should not be able to see the passwords. They should not be able to read them. They should not be able to write, meaning change them. So there's a read-write permission that they don't have on this, right? So we're going to come to this. We're going to come to the permissions later on. You see this word permission. Today's topic is permission. So let's finish this one exercise, take a break, and we're going to dive into permissions. So now what happened is root was able to go into these two files. Obviously, he's root or she's root, and they were able to see that. Tom, on the other hand, ran the same command that root was running. Tom is able to see one set of records, right? But Tom cannot view this one. So you have no permission, Tom. Now we have a message called standard error. This message is called a standard error, which we talked about over here. So you have a standard error, right? Which has come up. And so now what do we do? How do we handle these kind of errors? So we are seeing here that this is readable by all users. Okay, standard out, meaning this standard out, the first one you're looking at. Okay, so this has to go up. Sorry, and this has to go up. Yep. So you can see that you can see clearly that Tom is able to read, and so can all the users, a standard out, which is a 1. So they're seeing the standard out, but then Tom cannot see this one. Okay, this is the one that Tom cannot see. So this is the problem where Tom has. Okay, it's bigger for you. So now what do we do? So let's use the redirect to separate the files. Okay, let's use the redirect to separate the files. So how can I redirect? I can take this file again. I want to dump the information into output.txt. Okay, right? And the error that's going to come up, which is 2, I'm going to redirect that error into an error.txt file. Even though I did not use the touch command to create this, the fact that you use the angle bracket will automatically create this file for you. That's the beauty of Linux. You didn't have to say, oh, let me go and create a touch, and then I don't have an error file, right? So let me explain that to you. Okay. There's an output.txt file. Okay. There's an output.txt file. Let me remove that. RM. Let me see. Cat. Right? We have an output.txt file, and we have that output shows all the errors that have gone into that output.txt file. Right? That's what the user Tom is doing. The question Abby had early on, a very important question that I come back to now, I realize what he was asking me, is if I exit this, okay, and I look at the list, the practice lab I have is a practice lab 4. Okay, let me clarify this. The practice lab here that we created, practice lab is here, it is for root. No other users can see this lab. No other users can come out. Tom cannot see this. Tom cannot see this folder. Tom cannot view. Let's see what Tom can see. Let me not change that. Hold on a minute. Let's see what Tom can see. Let's not even debate that. So what can Tom see? Can Tom see all these that is under root? Okay. So CD, SU, that was the question that Abby, you had early on. I realized what you were asking. Okay. So let's go to CD /. Now Tom can see everything under the root directory. And Tom goes down the list and he says, oh, okay, home, that's me. Hey, let's check out root. Let's check out root. CD root. Permission denied. He can't go inside root. He has no permission to see what root is doing. You are the boss. So you can't just go into root's home and start checking things out. So no permission. So Abby's question was early on, will Tom be able to see that practice lab? Answer is no. Tom cannot see anything that root has got under his house, under his roof. So what can Tom have to do then? So don't confuse. We did create a practice lab under root. Okay, we created a practice lab CD. And the reason I created that, and I'm glad you asked that question, because that's a very key question to understand. We were creating a practice lab under root, right? And then we suddenly switched the user, Tom, and Abby said, well, you're tilde, but you're somewhere else. And he's right. I'm under my own home, but when I try to go CD root, I have no permission to see what is going on there. I can only see what's happening within my own house. My own home for Tom, I can see it. I can see the root's home. No way, Jose. You're not going to touch that home. Okay, so now let us go. We are already Tom. Tom created an output file. Okay, let's remove that file. rm-rf or just have an output. Don't even need that flag for now. You start adding those flags when you start getting some really bad messages, like you can't do it, it's not possible, use force, blah blah blah, a hanging file. That we're going to talk about those messages, why we add those flags. But right now everything is working smooth, so RM will remove that. Okay, so mkdir hyphen p as my practice is practice dash lab. Okay, now I've created a practice lab under Tom, and I'm going to cd into the practice lab dash lab. Okay, and cd practice lab. Okay, and I was check now. I do okay. I don't have any files under this. Okay, so now I want to do. I'm in my practice lab. That was the question, Abby, right? You had. So we can isolate the practice labs. If you're working as a user, create your practice lab in the user. That if you are working as root, create your practice lab as root. As you will see, the next hour that we're going to have after the break is a very interesting hour. And we're almost done with this key stuff. Now, I want to tail -n 2 records out of this password file. Okay, I can see that. I want to take 2 more records and see if I can see them under the shadow passwords. No, I cannot. If I want to just look at multiple records of multiple files, I showed you that you can actually combine that etc password and etc shadow. So now I have one output and a second output. Now I'm going to go ahead and do, I don't have any other files. Okay, do I have hidden files? I do have hidden files. Okay. Interestingly, Tom doesn't have the bash RC files and all those files. Okay. Very interestingly, we don't have any of those files because I was trying to delete Tom, and so let's not go there. This is a good thing to talk about. If you deleted something wrongly, you don't have the bash files. I mean, we can remove the user delete. Okay, that's like something didn't go right when you delete. So user delete should work smooth, and if user delete did not work smooth, then you have to come and look and make sure you're cleaning up the files. When we do patching and cleanup, we have a whole module on this. So don't worry about this now. If you see a problem, try to solve it. You have enough tools for that right now. So let's go up here, LL, no file. So let me go tail. Let me pull up that file because I have history. Okay, history 59, 53, 53, exclamation mark, 53. Okay, enter. Okay, exclamation mark, 53.
ojúṣe ń tu ẹni mi ò mọ
So-
mo rò pé ṣọ́ọ̀ṣì máa ń lo contact.
Yeah. So exclamation mark here. So now what I like to do is before I run this file, I want to throw that into an output. So I'm going to redirect that into an output.txt, right? And I'm going to say, okay, look at the output, the error. If I get an error, what am I going to do with it? I'm going to take the error, which is called 2. The error that I'm going to redirect it. And I am going to send that error back to 1. Let me explain this to you before we take a break. Very important to understand what we're doing here. I'll do a diagram. Okay. I am saying that this is going to give me a standard. This is going to give me a printout. Okay. Okay. And we said that this standard out is 1. And if you have a standard error, okay, sorry, 1 second here. Let's clear this up. So I'm going to send whatever has happened. We know what this is. Anything you type here, it's going to be put into this file. So you have one output, which is going to end up being a standard one. Why? Because we tested this out and said that Tom can actually read. He can read this file. He's able to read this file perfectly. So if he runs this command, he's going to get a standard out. He'll get 2 records. I'm trying to get 2 records. Tom is going to get 2 records. So this statement is saying that when I have this file you can read, 100% it is going inside the output file. This is 100%. This is 100% going here. But what about this one? We said this is an error. Where does the error go? Okay, we are saying this error is 2. I want you to take the error, whatever this is coming, this error here. Take the error, this is the error, right? Redirect it and put it back where you're putting 1. Dump it into the output file, output.txt. Just push it there. So you're basically saying in the output, I want to see the error and I want to see the good stuff. The good and the bad, everything goes in this file. Okay, so let's take a look at that. Let's take a look at that. So you have in that output file, this is the output file. Inside the output file, you have 2, which is the error, and you have 1, right? This was going to go anyways. This is 1 and this is 2. 1 and 2. In order to put both 1 and 2 into the output, you're going to say take 2 and put it where you're putting 1. This was 1. This is good. The standard out was good. So that's here. And I wanted to put and take this 2 and redirect that and put it in the same file. But let's do something different now. How about we want to separate the 2? If we want to separate the 2, I have to remove this guy out. And I can say, take my 2. I don't have to say 2 to output.txt, right? Which is what I was doing here. This and 1 is the same thing as saying, put this in the txt and put this in the txt. Now I want to say, just put the good stuff in the output and put all the errors in another file called now let us look at this. So I've separated completely my outputs. Okay. This is a little bit, we'll take some practice. Now let's take a break. This computer again. Okay, let me share my screen and let's go and let's see what we can do here. When we have some chat. Okay, great. So Right. So we have done all of this. We have done our RM-RF, RMDIR. Don't worry about this. I'm going to fix this up. I started writing. I'm going to give you the grab and pipe commands. We can add to this. There's another very powerful command, which is the stat command. And I think I'm going to clean this up before we do this, because hard links and soft links, we're going to do them next week. I don't want to confuse too many things. But we are going to use the stat command today and see what the stat command is actually, how the stat command actually works. So we left off yesterday talking about unconfined and confined, right? And Khalid Khan had said, put some information out. But we're going to get to SE Linux as a subject. We're going to do our website. Then we'll be able to really understand what's going on. But today we are going to focus on the next 45 minutes. I'm going to take all of that out. Is user and file permissions. Okay. User and file permissions. And we're going to look at ownership. We're going to look at Chamod. We're going to look at all these files that we are. So if you have a file, as you can see, and you want to change the ownership, like this classroom, the student is saying, hey, how do I change ownership? Okay. What are ACLs, right? What's file ownership? Which is change the ownership, change the group, change the ownership, change the group. What is umask? Get ATTR, set ATTR. We're not going to get up to this point, but we're going to get up to the basics and fundamentals of understanding all of this. Okay. So this whole class is about Linux file permissions. There are 5 or 6 questions on the Red Hat exam. 25% of the exam carries weight on the line of Linux file permissions, right? Let's look at the next thing. So in Linux, you have DAC, right? Which is that the owner of a file has control over its access permissions, right? And there are 6 things under DAC that we need to master. These are the 6 things that are a Linux system admin must know in order to be an expert in his or her trade. So we're going to start out. We have looked at the etc profile. We're going to look at it again. So we're going to look at, when we look at file permissions, how ls-l, we have been using it for a long time. You can see the command examples. So that gives you a good overview what we're going to do. We're also going to cover the access control list. Okay. And there's some few additional mechanisms that we're after the special bits, the extended attributes, and how do we manage the files, how the owner has control over its access permissions. So if you're the owner of a file or directory or root or a group, how do we manage this? So let's understand this stuff. 25% on the exam. This is the major aspect of Linux that people should understand and know. So now Linux has some predefined permissions. What do you mean by predefined permission? These are hard coded in the Linux kernel. Okay. These are hard coded in the Linux kernel. And when we are talking about permissions, let me remind you, we are talking about, let me move this up. We need to move this up. This is, before we even come here, we need to go here, right? Okay. So we have, this is, the date is pretty bad. This is, I picked up an old slide, which I was trying to remove. Yeah. So what we have here is when you do ls-l on a file, and this is as the root, or as the user, right? You take any file we have created, it gives you the metadata, right? It tells you the file type, right? If you look at the first sign, it's the file type. It tells you the owner, what permissions are on the owner of the file. If you created the file, this will show you the permissions, whether you have read, write, or execute, right? And whenever we create a user, by default, the group of the user is the owner himself. The name of the group is the owner's name. So you're seeing this output, right? These are permissions on what? On the file. What do we have here? Let me remove this. Take it off. Wait a minute. I don't want to use the pointer. Okay. What I would like to do is just take this one here, yellow. So you have a file type. This file type is either a directory, which will be, you will see a D in that position, or you will see a dash in that position, which means this is the file, right? When you create a file, this is the file. Okay, that's why it says this is the name of the file. Okay, when you use the touch command and you create a file, you're going to get all of this data attached to that file. It's going to give you, we're going to look at date stamps. Okay, what are these date stamps? You know, is this the actual date, which is, you know, there's the ACM philosophy behind this timing, date and timing. So don't worry about that right now. Where is this timing coming from? What is this? Is it real time? Is it modified time? Is it actual time? What is this date? So don't worry about that. We have just a small topic next week just to cover that. That's not going to stop your business, but time is important, right? Then you have the name, the owner of the file is John. The primary group of the file, as we can see in this picture, is Unix, right? But usually when you do user add command and you do the ID, you're going to have here John. Okay, you're not going to have Unix. You won't have this. So let's look at that. So when you create a user John, oh, come on. Okay. Now, let me share this with you. Okay. So we went into Tom's environment and we looked at the files. Let's just do the CD. Okay. Now, Tom created two files, right? So let's clear everything out. So Tom has ls-ld. So I ran two commands. ls-l, sorry, with ls-ld. Wait a second. Where's the ls-ld? Yeah. Let me clarify this. Okay. Let me change this name. It's very complicated. Let me move this practice. dash lab. Sorry. Okay. So we have, if I do LL, okay, I can see that I have, this is the directory, right? It has some permissions, read, add, execute, read and execute, read and execute. Okay. We have two hard links. We haven't talked about them. This is Tom, okay, and his primary group is QA. Now we had changed that. So his primary group was QA, okay? And then when he created the files under this group, right? It was let's go CD practice lab, right? His group is showing as QA. But let's exit and let's see what are the users we have in this CD home. Let us look at lab user. Okay, our lab user was changed to. Let's look at student. Now see that we have changed the group of lab user yesterday to QA, right? Okay, so Tom has a user group, Tom. Let's take student. Okay, so when you create a user add, right? Like student, and let's go ahead and see the student here is CD, let's see, SU student, right? And if student creates a file called file, and we look at the permissions on the file, we're going to see this. And if student creates a directory called dir, we can see that, yeah, this is what I wanted to show. So let's do it simple. So student is a new user. Okay. So if you look at this permissions carefully, you can see that you have, this is a directory. So by looking at the D, you can see this is a directory. And this is the file, right? Let's use different one. Okay. And if this is the file that you're looking at, this is the file over here. Now, we have a set of permissions that you can see underneath, right? You have, for this particular one, you can see you have these permissions, right? And for this file, you have some permissions. Now, these are default permissions. These are default permissions. And there are only three. Can you read a file? Can you read what? Can you read a file or a directory? Can you go into the file? Can you CD into the file? Can you read? Can you write? And can you execute? Anybody who can tell me what do you mean by read a file? What command do we use for reading a file?
Cat.
Thank you.
Cat.
Get command. That helps us to read a file. Okay. We haven't done writing the file. We're going to run how to write a file when we do scripting in Xfig, which will be using the editor, VI or Vim. We have two editors. We're going to learn about how to edit a file, which means you can write a file, you can pick. But we have done something called echo, right? Without you opening the editor, if you want to write into a file, we have used the echo command, echo. Okay. We have also used the directional and the redirections. We have used all of these because we're able to write. We said we can overwrite, we can append, we can overwrite, we can append, right? So we can do these two things. So let's look at this. Let's look at this default here. Okay, let's look at the default for the file. Okay, so let's clear all this away for. Hold on a second. Let's clear this all away. Clear all away, and let's get a color that our eyes can manage better. So you look at this one here. Okay, this says that I have got a file. Okay, and the file is RW dash. So read, write, and we said there are three things we are going to look at: read, write, and execute. Execute is very important because when we have to run a file, an application to test it, we're going to use execute. So far, we said you can use the cat command, right? We also said you can use the directional commands. We can use echo. We were able to write to this file. We're going to learn about VI and VIM. Okay, this is coming up next week, not now. So far you have learned pretty much a lot about writing to the file. Can I write to this file? If this says RW, okay, and then there's another R dash dash, then I have another R dash dash. You can see this string, right? So this is the file. I have this one here, and then I have the second one, and I have this. What is it? File. You said touch command, touch, and you created a file. And then you do ls-l, and you get this output. Okay? All this line output, ll, right over here. It is telling you that this is the file. This file by the user. Who is the user? Who is the user? Student. Who's the owner and the user? Owner is student. So the owner, the student, by default, क्या माना इसका? What is the meaning of this? Default का? That the Linux kernel, which is a C program kernel, okay, the Linux kernel has a umask, hard programmed, hard coded. There's a umask code. There's a code in here in C language, and that code sets a basic value of 0. I think 0022. We are coming to it. So the kernel has this value, and this value means something in shape of what you're seeing. So this is hard code, meaning it is hard coded. It's in there, in the system. Okay. We don't change that value. We can temporarily, but when Linux, anytime you use a touch command, when you use a touch command, okay, it goes into what the hard coded value, and it goes into the profile. It looks at that value that is hard coded, and it applies that value to everybody, to all the files you're going to create. When you initialization will give you all the files that you have to create. So the student has only read and write, no execute. What about the group? Okay, what group is he part of at this moment? He's part of the student group. By default, when you create a user add, okay, a group is assigned to the user, and the name of that group is the same name as the user. So this group, which is called student, has only read access. It doesn't have write access, it doesn't have execute access. Same thing applies for others, who are others. This account belongs to student. This is an account for student. This is student's account. Similarly, you have Tom's account like this. Tom has an account. Similarly, you have other people here who have an account. Maybe tester. These are all users. These are called others. These are the others. So they only have read access. What that means is when student creates a file, right? When student creates a file, the student can read it. The student can write to it because they are the owner. They can change the permissions on this, and by default, they can execute. So they have to change the permissions to make it executable. But if student was added to a QA group over here, QA group, okay, then that QA group can only, if they were part of a QA group, if you give permissions to a QA group here, QA group, that group can only have these permissions. This is it. They can only read. Why? Why can they only read? Because there's only read permission given to them for this file. They cannot write. They cannot write. They cannot execute. What about others? What about Tom? We saw that Tom cannot see anything in the root folder. Tom has no permission to go to root's home. But Tom has permission to look at students' files. And like the group, Tom can only read. Tom cannot open Asim's file. Tom cannot open Sahid's file or Ifra's file or Adelovo's file, Abby's file. You'd use a touch command. You created a file. No, all of this other students in the class, all the other employees of NIT, they can only read because the permission given to them is only to read. These guys can only read. These guys and girls can only read, right? Because for anybody other than a group, their permissions are just read only. So if this is Asim's file, I cannot get into Asim's file and change it. I can only read it. Okay, let's check it out.
Nadim, just one
Yeah.
quick question.
Yes,
I
sir.
will just may sound very silly, but
No,
this
please.
yes, we have read, write, execute. So what does the execute function do?
We are going to come to that. We are going to come to execute next week. And what
Okay.
execute does it that when we write, when we do automation, this is an automation because when we start to move from Linux to writing a script and to doing automation, okay, we want to automate some tasks. So we are going to open a file. We're going to create a file. We're going to create a file, okay, and when we open that file, we're going to put some things inside that file. Some very simple steps, okay, meaning that this file is going to check. So let's say we put in this file input. I'm simply we say input read. Okay, let's just say one line, input read. And well, the file by itself cannot do anything. The file, let's say, is called an input file, input.txt. Now the file by itself cannot do anything. So when you look at the permission of the file, if this file it doesn't have any by default, the Linux system has a default system. By default, you can see that X, nobody can execute, even the owner. Why? It's a default permission. Linux has been designed so people don't start running programs by mistake. You can have a cleanup program. You can have a RM hyphen RF. You want to put here RM, dir. When you run this 2 lines, at the end of the day, you clean all your house. And we are going to show you that a cleanup. What is a cleanup file? But the file by itself cannot do anything. It just sits there. You have to come back and make it executable. And the way Linux understands a file to be executable, when you put a dot and you put a / and you say input, right? .txt, we are going to find out next week that this syntax, by putting a dot and putting a /, it makes it executable, meaning the program will actually run in the Linux shell, like a Python script will run. It is going to actually treat it as an application program. It's going to take it and it's going to read it line. Okay, how do I understand read in this? It'll go into the file and say, okay, this guy is asking me for input. Okay, so your screen is going to go like this. You will have a blank thing blinking. You will have a blinker blinking. And if you say to it, say input equal to, it will be sitting here with your cursor and it will be blinking. It's because you have told it, hey, give me an input. Once you give the input, let's say you give the input AB is equal to 100. Okay. Now the line, it will go to line 2. It has already got the input from your standard input, your keyboard. It's asking you put an input. You put an input. Now that within the file, you will say, what is AB 100 will do? Oh, AB is user root 01. Now I can write a statement, say, okay, if AB is the word you see the word AB, then let's go and do this. If I don't see AB, then let's go and do this. It's like you come to the stop sign and it says, I can go right, I can go left. Okay, if the light is red, I have to stop. If the light is green, I have to go. So there's a script which allows us to do execution. So we are going to discuss how to execute using what is known as bash scripting.
Okay.
Bash scripting. And that's why we're going to teach that before, so that when you do your Python, you will be very comfortable running programs. Simple. You will actually become officially a developer. All of you will officially become a developer. Now, do you need bash scripts at work? Yes. Do they require off of you every day? No. Maybe 1% or 2% or 5% or 10%, but some jobs are very heavy. I know within our own team, people who write bash scripts, every month. So they're really good at bash scripting, right? But we want you to be just comfortable with bash scripting, knowing the power of bash scripting and how to run a script, how to automate your environment, how to do tasks that are too much. If you have one machine, and in our data center, we know we have 100 machines, Abby. And I said to you, you have a task as a Linux admin that, okay, let's go and update the IPv6. Remember that problem I gave in the very beginning? Everybody
Yes.
had to log in. Abby
Yes.
logs in. I log in. Right? Until today, we see those machines are having problems, because when we restart them, the problem comes back again. Now, if we created that problem, and I created that problem intentionally to teach bash scripting, because one of the script we are going to write is, we had to run some commands, sysctl on day 1, right? Sysctl hyphen what a w, blah, 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 such a long line. Okay. Now I have to open this one machine. Then I have to open Ifra's machine. I have to then go and open this machine. I have to if I have to open 100 machines and run that command 100 times, it is very hard. Okay. In a data center where you have 1,000 machines, It's impossible. It becomes near impossible. So at that point in time, you have to go to scripting. You have to create a script like a story of a movie, very simple movie, and you're going to tell your movie, you're the director of the movie. You're going to tell them exactly what you want out of this movie. I want you to go inside this file, OLinux, find all those IP addresses that need to be blocking IPv6, and I want you to go and run this command on all these servers, and that's it. That's all I want you to do, and fix my problem for me. But how do I run this command? How do I execute it? How do I execute this file? Only way I can execute this file is by using this kind of syntax. And when I hit that dot / my file, you will see it running in Linux. You'll see the file is running. We can check and do the background process. It's going to show you all the IPs it's going to check. It'll find the IP number, .1, .2, .3, .4, .97, 98, 100, 105, 200, 250. It'll go through all the IPs, and wherever the machine is there, it's going to update that for you. That's what execute will do for us. Very good
clear.
question.
Thank you.
Very
Very
good question.
clear.
I am going to add this because of your question. I'm going to add another slide. So please, everybody, be patient. After this class, obviously, I'm going to take a little bit of rest, and then I'll come back and update the slides. It won't take me much, but this question is very good. And now we can see the value of execute. So it's just a flat file. So now we understand. This question has helped us to understand. I think for everybody, it helped everybody understand something very well. That number one, let's clear all the drawings. Number two, that default. There is a default in the system. Oh, this is not a good color. This one is no red in default. Okay, it's all going to be default. So default there's a name for default, and that is called umask. Okay, and let's start talking about this now. Let's get into the business of understanding what we're doing. We have a user called student. The student used the touch command and created a file. The student used the mkdir command and created a directory. When we did LL, we were able to look at the permissions on the directory. We were able to look at all these permissions, and we're also able to look at the permissions on the file. We have a bunch of other things called hard links. We're not going to worry about that now. We can definitely see that the owner is the student, okay? And we can see that the group is the student, okay? We talked about this 6. We'll revisit this again. What is this date and what does it mean in the system? I won't worry about that right now. I won't worry about this. So you keep your mind clear. You don't have anything to clutter. I'm going to literally remove this out of the picture so your mind doesn't keep going here. Because if you keep on going here, it's going to keep throwing you off. If you keep on going here, so if you look at the picture it's simply as column 1, right? You have an owner, right? And you have a group of that owner. Very straightforward. So you have a user, you create a user, and that user is called student, okay? And that user has a group called student. And this student is part of a group called student. How do we know that? How do we know that? We can simply come here and type the ID of the student. I'll tell you that this is the ID is student. The group ID is also 1000 student. And is he part or she part of any group? The group name is also student. So nothing changed. So this is all default. Okay. Now, let us get past this very basic stuff. We may have to carry this class over to next weekend and let's get to a point where we can do the labs this week. So this one here is telling us is telling us that these are the permissions. This is John, the owner, and we can change his group, and we're going to do that very soon. Let's go to the next slide. Let's move now. So there is a UGO, right? This is the UGO. UGO is user group others. User group others, right? And so UGO is, we're going to find out, you have this is the user, this is the group, this is G, and this is O. U, G, and O. User, group, owner. Others. Sorry. Others. Okay. The user, reason why we don't use owner is because there's a O and there's a O. So what Linux designers did was they changed all of that. They just decided to call this U for the owner, U for the user, G for the group, and O for others. So we want, anytime anybody wants to look at this file, there's always going to be three types of people. Either you, the owner, is looking at the file, or you are part of a team and a group which is looking at your file and working with your file, or you have those who are not part of a group, but they have others, but they want to look at your files. Okay, maybe a designer and an application developer who's not part of your group. They want to look at this one file you created that they need to use also. So there's somebody else outside the group who wants to come inside and look at it. So by default, we are saying that if there's anybody, when you create a file in Linux, by default, Linux is telling you, hey, hey, all of you there, Ifra, Adelo, all of you sitting out there, Asim, please understand this. When you use the touch command or mkdir command, look at the permissions that you have. What permissions do you have? Okay. And those are read, write, and then read for group, read for others. Okay. Now, very clear. Let's look at this, right? Let's look at this table that looks a bit fuzzy to us. But it's gonna be very easy to understand how this table is working. Now, in any file and directory, for any file and directory that you have, okay, for any file and directory, right, everything is hard-coded in Linux. Linux gives a value of 6 for the user, 6 for the group, and a value of 6 for others, okay? And we're going to find out what is 6, okay? And then for the directory, it gives it 7, 7, 7. And down here you can see here, I've written, we are going to run a command. It's going to show you that user is umask-ask. It's going to tell you rwx, G is rx, and then this is rx. So you have rw by default, r by default, r by default. So what is this? What is this 7 and 6 that we're talking about? Okay. So read, write, and execute. Okay. You have if you can read a file,
4.
I believe it is what, 4?
4.
4, right?
Read is 4. Yes, 4.
Yeah. So read is 4, write is 2,
2.
execute is 1. Thank you, Saeed. Thank you. I actually even my mind went blank. Thank you for helping me. So read is 4. Read is a value assigned by Linux machine as 4. So the total sum of this is 7. So when you see 7 here, it means it has all the permissions on it. If you see 7, it means all the permissions on it. Okay, but now you see that they're not all. So what is going on here? So let me remove this and let me clear this up so that we don't confuse right and left. What we are actually doing, ladies and gentlemen, is that UMask is right here. Yep, UMask. This is the default, okay? A value that you have set in your profile for Etsy profile. So the system starts with 666. That 666 value goes over to the UMask, it goes to the Etsy profile. Etsy profile value is set at 0 to 22. Okay. So what it does, it does a mathematical calculation. 6 minus 0, 6 minus 0 is 6. So you got 6. 6 minus 2 is 4. You got 4. 6 minus 2 is 4. So default value is 644. Okay, on files. Default value on directories is 755 because you take 022. Let me change this. Come on. Okay. So what it does is simply it's going to take the hard-coded value coming from the kernel. When you say user add, it's going to take 666. It's going to go to the profile where you have the UMask. It's going to minus this 666 minus 022, and it is going to give you the new permissions. So default is working this way. 644 755. You can memorize this. Okay. So let's look at it in here. Exit. Clear. So UMask. What is the UMask value? 0022. Okay. What is the UMask minus S value? Okay. Which is saying that read, write, execute. User has read, write, execute. Group has read and execute. And O means you only have read and execute. Okay, let's see over here. What does it give us at 0? A 6022. Okay. If we go into the cat into the Etsy login.defs, let me go there. Oh, that's cat. Okay. Oh, we decatted. Okay, fine. So let's go to the UMask. Login retries, and there's 022 is the default value, but 027 or even 077 could be considered. Okay, and let's see whether UMask value. 022. Hold on a second. So we go into do we have a UMask here? No, it doesn't have a. It's the history other command, right? It's the login defs command. So it sets it at 022. And let's see, where do we change that? I haven't changed it. I haven't touched it in a long time. Let's see. Yeah, it is in the login defs. If I remember that. Let's see. Clear. Let's go VI. Let's see. Login defs. Right. And let's go. There you go. we're going to learn how to get into a file and search. So everything I've searched here with UMask, there is a default value. Fastest way to find the value, you know. So UMask 022. That's if I now come back and look at UMask, right? I hit enter, and I'm right over here, and I inserted anything. I can go and change the UMask value of the default. It said, what can you change it to? 027 or 077. 077. Okay. Okay, wait a minute. Let me quit without changing anything. Let me quit without changing anything. And so right now it is going, read is 4, right? Read is 4, write is 2, read write. So 4 plus 2, 6. So this is 6. So this one here gives you 6 because it is 4 plus 2. And you don't have to do all of this math, okay? Because we don't change these values in the system. This is 4 only, right? And how much is this one? This is only 4, because this is only read, and this one is read write. This is 4 plus 2. So 6, 4, 4, and because you take 6, 6, and 6, you minus 0, 2, 2, 0, 0, 2, 2. Okay, that's weird. What's its default giving us? So this default is giving us okay. So we have 6, 4, 4. Yeah, that's right. So it matches that. So that's the default value. And if you look at a directory 777, you minus 0, 2, 2 from that one, you're going to have 7, which gives you 5, 5. Okay. This is based on the UMask value of 22. If I change this value now and make it 0, 0027, okay, then it's going to be 666 and 027, 777, 027, and it's going to come out to be 6, and it's going to come out to be 4, and it's going to come out to 641, and this is going to come out to be 7, and it's going to come out to be 5, and 0. So we can change the UMask value, and let's not do it right now. Let's not spend too much time on changing the value. We don't need to change the value. The default is what everybody uses, unless you have a special case applications. 100% of the time, nobody changes the UMask value. So we can not spend more time on this and get to the, because we are already reaching at 2 o'clock. We need to cover a lot of material. So that's the UMask. So I hope you understand this part. Now, how many slides? Oh, 475 slides. This is not the final one. Okay. So the UMask value, you basically change it. I'm not going to go into that. This is basically showing you how this one slide is there to show you the breakdown, directory, group, ownership, and others. I pulled this slide because it was very nice. I'm going to clean it up and leave it there. This particular one was to talk about the 3 permissions. R means the user can cat, touch, less, grab the file and read a file. And write means user can VI, CP, move into the file and write to that file. X means the user can execute. So I hope that is very clear. I'll make it even more clear later on. We have a little lab in which we basically go and test all of this stuff that I just showed you. I'm not going to go into that. We have the login.defs, which defines the UMask. We have another thing that the login defs talks about. And the only value of this slide at the moment, ladies and gentlemen, is that there is a system within Linux called PAM. Okay. And I'm going to leave it at that. Please don't go deep into it. PAM is a complete science of its own. It's a security mechanism. Okay. And if we get time towards the maybe end of the Linux course when we're ending and we have an hour, remind me, we'll go to PAM. PAM is a lot of the security stuff which deals it goes with PAM. So I wanted to highlight that to you, that there is something called PAM that we're dealing with. Okay, access management. Remember, we talked about AM is access management. So leave it at that for now. You can read this. Let's go into this. So we have read, write, and execute permissions, right? Read, write, execute, right? There is a calculator, Chmod calculator. Life is made so easy now for everybody. You don't have to take a pen and pencil like me and say, okay, if I want to read, that's 444, RRR. So for practice purposes in the lab, I'm going to have you open the calculator. I'm going to ask you to say, okay, give the owner read and write permission only. Give the group read and write permission. Give the public only execute permission. So 661 comes out to be read write. Your math, you don't have to sit there and do the math. Nobody at your job will give you another extra rupee, naira, or dollar in your pocket if they knew that, oh, your math was right or wrong. Wrong, you got a problem. Right, you get no bonus. So don't try to go after a bonus to prove yourself you're good in math. I'm not good in math, so I'm not worried about it. Use your calculator online. It's going to calculate for it. If your mind is itching to check your mathematics, go for it. Pull a piece of paper, go do the math, and prove it to yourself that this thing works, because that's how we all are, right? So now let's look. What do I mean by 2? Why do I have 2.0 on the top? So please remember that I'm matching 1.0, 2.0, 3.0, 4.0. So this whole notes, when they come to you, when you all see 1.0, we are going to be discussing everything with UMask. When the slide changes and you go to 2.0, come back up here, or I may actually just keep putting this table to remind you that you're actually now looking at read Chmod. So we have already looked at UMask and Etsy profile. Now we're looking at Chmod and ls-l, right? Remember, 25% of the exam is on this table, 25%. So we are going to review this table quickly. Now, 2.0, read, write, execute permissions. Okay. What we are going to do is I want you to set up a lab, right, in which you're going to add 3 users. User add tester 2, 3. Then you're going to use the echo command and echo the password by using echo and a pipe. And I'm going to put that slide that I told you I wanted to update for you. So by the time you come down here, you will understand what the pipe command is. The pipe command is basically saying that go into the password and put a standard in for tester 1. Don't worry about how the interpretation. Just follow this as is. Add their passwords. Add 3 users as root. Why as root? Because nobody can create users except root. Let us then add a group called Linux team, okay? And assign them to the tester 1 and tester 2, okay? I'm going to run it with you guys if you want me to. Then let us make a directory for testing, which we did. We already have a directory for testing, right? And hold Hold on a second. Hold on a second. Hold on a second. Where are you, buddy? Where are you, buddy? There we go. Yeah. Right. We already have this in place. Next, you're still root. Remember, I'm giving you the notes. Still as root. Let us create a file. So you're going to create a file, touch html01.txt. Remember, we are in the practice lab, a question that Abby had asked. So we are still in the practice lab because you can see, right, directory. Unfortunately, here I'm not showing that. I need to update that. Okay, that's fine. And then let's give the permissions to that file. Okay. So what does that mean? Chmod 644. Let's do that real quick. Okay. Let's create. Are we recording still? Yeah, we are still recording. Okay. We are almost at 2 o'clock. Let's do this lab. We can end it. Kind of get you started. You can do the labs. If not, we're going to continue next week. So I'm going to end it with this one to get you guys started on read write access. Very straightforward to follow, right? What do we do? Number one, I am going to clear pwd cd clear. I'm going to create a user add tester1, user add tester2, user add tester3. Now I'm going to do echo ABC. I'm going to pipe command. I'm going to put in what do you call password -- standard in. Let me go back here to show you guys what I'm doing. And I have it all here for you. Tester1. Okay. So standard tester1. The reason why we're doing this is on the Red Hat exam, you got to learn how to use this command to change passwords. So you can just do password and it'll work fine too. Okay. So if I hit enter, and now all I have to do is change it to tester2. And all I have to do is go to tester3. So very easy way to do how to change passwords. Standard in, tester3. We will talk about how this statement works when we do the pipe command. Don't worry about it for now. So now we have created 3 users. Okay. And we are saying in our lab, what are we saying in our lab that you guys are going to do? We have taken care of all of this. So let us add a group called Linux team. Okay. Let's add a group called Linux team. User, group add. Do we have a group add? What do we do here? What am I doing here? Let me see. User mod. Oh, I don't even have a Linux team group. So first of all, I don't have what do I have the Linux? So I'm going to add one more line to this. First of all, we have to create the group. I want you to practice how to create a group. So you're going to do group add. How do you check first? How do we check if we have Linux team? Anyone? We do basic tail, or we can do grep Linux team from etc group. Nope, no output, nothing there. If I do tail -n, last 5 records of etc group. Nope. There's a new group, but we don't see any Linux team. So I'm going to go group add Linux team. Now I can do a grep, and there it is. Linux team is there. I can look at the last few records and I can see Linux team. Okay, I've added that. This is the practice for yesterday's lab. We're kind of doing the continuity, connecting and understanding this clear. Now, we're gonna end this class on this note. Don't worry about it. Just bear with me for a couple of tasks here. Okay, I've done the user add. given them the password, created a Linux team group. Now we want to modify. Okay. I want to go ahead and modify tester 1 and tester 2. What do you mean by modify? If I look at the group that Linux is, if I look at the ID of tester 1 and I look at the ID of tester 2, I see that they don't belong to any group. Okay, they just belong to the default ID, default tester. Now I'm going to go and do user mod -gg Linux team tester 1. Oh, sorry. We don't have user mod. I have a primary group. I'm changing. Sorry, not the secondary. Sorry. Linux team tester 1. Okay. This is Linux team. Okay. Now, ID of tester 1. There you go. Tester 1 was initially, group was just tester 1. I've changed the group to Linux team. Let's do the same thing. ID tester 2 and user modification. Which user am I modifying? Tester 2. I can do it this way too. Tester 2. Or I can simply just put the flag. I want to go and modify the group, giving the primary group Linux team to tester 2. Now I can do the ID and I can see that, ID of tester 2, Linux team. So now we are done with this task. We go to the next task, right? Still as root, we're going to create a practice lab. So let's look at the practice lab. We do have the practice lab. That is done. We have to do nothing there. We're going to create a file inside the practice lab. So we go into the CD practice lab. Okay, there's nothing in here. I want to touch HTML 01.txt. I've intentionally picked a very strange number like 01. Sometimes you don't get clean files. You don't get a simple file like HTML. It could be a HTML 01. But I'm going to change that. I want to change that and make it simple for everybody. We don't need to do that. Okay, touch HTML 01. What is it next? Let's look at the permissions on this file. ls-l. We have the default 644, read, write, 4 plus 2, write, 4, write, 4. Owner has read, write 6. And we can run another command called stat HTML 01.txt. And this statistics command tells you got a file, right? I don't want you to look at all of this right now. We are not talking about any of this. It gives you the inodes we have studied so far. Tells you the UID, okay, is root 0, group root, context, unconfined. We have talked about this. Remember the timing stuff I talked about? We haven't talked about this yet. We're going to have a dedicated 15, 20 minutes only. I'm putting away all the easy stuff to the end. I want to do all the heavy lift in the front. And then when you guys do the easy stuff, you will really have fun. So have we covered how to create a file? Yes. Have we covered inodes? Yes. We know how to look at an ID? Yes. We are now looking at access. 0644. You want to know everything about that file? It's telling you that 644 equals to read, write, write, write. Okay, fine. Context, we'll come back to this eventually. So leave it alone. We'll come back to all of this later on. So you have a statistics of the file. Now, what else do we say here? We have got 644. Let us give permissions now. What do you mean by let us give permissions? Meaning, let us change. I'll change it over there. Let us change the permissions. Okay. So let us change the permissions. And the change permission command is chmod. Okay. And what do you want to change it to? 644, we already have that. I want to make it 600. Okay. 600. So if I want to do 600 on this file, html01.txt, I'm saying I want to change, I want to modify my permissions. Default permissions are 644. I'm now changing them to 600. I'm going to change what you see here when I run the stat again. So I said, look, let me change that.
Maybe because of the forward slash or the backward slash.
Or you have to
Thank
put
you.
a 0
Thank you.
before 6.
Thank you. The forward slash. Exactly. It doesn't exist in that path, does it? And I'm making that mistake. You can see. And because I'm rushing and I know you guys are tired and I know we are a little bit over the time. So because of my rushing, I'm making mistakes. But look at that. Now look at the stat. Let's look at the statistics. Let us see what changed on this file. Aha. 644, 600. This went from read, write, write, write to just read, write. But how about I wanted to give myself, I'm the owner of the file, and I want to give myself full permission. So I can go chmod 700 html 01.txt. Seven hundred. Read, write, execute. 4 plus 2 plus 1. 6 plus 1, 7. Total is 7. Okay. So now let's finish this lab so that everybody understands it. So we had read, write, write, right? And we went to 600. Okay. And we made this basically 0, 0 and 0, 0. It was kind of like that. I'm going to fix that for you guys later. So that's just to show you that you have that, right? So permissions came out this way, right? Owner was read write. This one is none. And this one is none. So in your assignment, I'll ask you to change some values and I'll give you a table, owner group, you're going to have and say, okay, this is read write and execute, or this is just read write. So this is giving us, what does this mean? Read write. So this should have been, this here should be here. Okay, now we are on the same page. Oh, this is a long save, I forgot. Okay, so going on to the next one, we changed it to 755. And the whole idea of now you guys can understand and appreciate that we are looking at this table again. Ladies and gentlemen, this table over here, what we did was we took the chmod command, we have used the ls-l command to view number 1, and then using the change mode command to change our read-write permissions. And we have successfully understood what the system does. We have successfully been able to make changes using the chmod command. You are almost 5%. Today you have learned about the Red Hat exam. Okay, you have answered a very serious question on the Red Hat exam by going this far. I want to see what we got here real quick. How many tasks I had put together. Task, yeah. So there's quite a bit of tasks here. So we will leave it at task 2 is 1 line. Let's do it. Let's do it so that we can enjoy the week. So task 1 was read write. We were looking at owner, group, others, right? Everybody now can appreciate and recognize this particular part of the equation, right? This is the equation we were trying to understand and explain with this task one. The whole goal of task one, look at read, write, execute. How can I change it? Chamod. How can I look at it? LS minus L. You done. 5% on the exam. You are ready. Okay, if you understand this part. Task number 2, another 5% I want to add before I leave today. Okay, and I know you're tired, but I'm sorry, we'll just do this. Let us check ownership on a file. We have all done this, right? We check the ownership on a file with the ls-l command. Let us change the owner now to tester, okay? Now, this is an important one we're going to do. There's one page, one slide. Amazing, amazing. If you understand the concept, how quick you can learn everything on that table, and how challenging it is if you're just watching videos after videos and people are just throwing information that you can connect together. Okay, so now let's do this. We said, let's check the ownership of this file. ls-l html01.txt. Who is the owner of the file? Root. What's the group? Root. Right? We see the permissions here. Let me restore the permissions back. Chmod 644 HTML 01 on that file. Okay, on that file. If I create a new file, the defaults will kick in. This does not mean that the system has this number now. Only this file has been changed. If I created a new file, it will have the defaults. If I've already changed, I've already created a file, I can use chmod to modify the file permissions on that file. I hope you're clear. Now, what does the lab say to us? It says, we want tester 1 to become the owner. So change ownership. Okay? Change ownership. Currently, the ownership of this file, ls-l of this file, the ownership belongs to root. Ownership belongs to root. The root is decided that Abiwari is our new developer. Ifra, Asim, Sahid, all of you guys, Umer, Walex, Mubarak, Ibrahim, Momen, I don't know, everybody, Emmanuel, all of you guys are coming on board. We need to take one person in this team that's going to have ownership of this file. That happens to be the lead of the team. Okay? So all of you are a part of a lead team. So we're going to change your ownership. We're going to change ownership. Change chmod or change/modify permissions, right? We have done that. So we can change the permissions as you see. 644, 755, use the calculator, you're good to go, you're done. Okay, how you get read, write, execute, you know how to change that. We are moving on. We have done this bit of the equation. We are not doing this. We are not doing this. We are only treating this one now in the hospital. How to change this? We have learned how to change this. We are learning how to change this. And we are going to also learn how to change this. We're going to call it a day. Now, chon is ownership. I want to change the ownership of which file? Of the file html01.txt. That's the best way to learn this Linux. You put the command chon. What does chon do? It changes ownership. Ownership of what? Ownership of this file. Now you're clear in your mind. You can go up here. You can hit a couple of spaces. Come back here. Ownership will go to who? Tester 1. We're going to change this ownership to tester 1. Now, currently the owner of this file is root. Let's do ls-l. Guess what? You have now learned another 3% or to 5% of the Red Hat exam, because they're going to test you on this capability, how to change the ownership of a file. They'll give you a file. They're going to make you do a bunch of things to confuse you, and you need to be clear in your mind. ls-l, you're the pilot of the plane. This is your gauge. You run this. This is the output. Go step by step. What is the Red Hat exam asking me? Should I change the permissions? Then that means chamod. Shall I change the owner? That means chown. Shall I change the group? Well, that's the last part of this. So we are going to change the group. Change group. And we want to give, right now the group is root. The file, we want this file to be part of a group called what? Linux team. Now let's look. We have successfully, ladies and gentlemen, changed the permissions. We have successfully changed the owner. We have successfully changed the group to which this file belongs. Okay? We have successfully achieved this step by step. And we have done that here. How about we do all of this in one shot? Okay? I can change, use the chown command is so powerful that you can go tester2 Linux team or QA and then html01.txt. There you go. I changed the ownership and I combined these two things. Rather than using the group command, the chown command is powerful. You can just change, let's change just the QA using the chown command. Chown, if I put the colon, it's like a seesaw. CH on the left, CH on the right. CH on the left, CH on the right. When you are in the middle, what is the riddle? It's called church. Okay, so right hand is a riddle. Okay, now you have on your right hand side, if I just put in here simply Linux team to html01.txt, that's it. By using chown, I can avoid the group. But at least you understand how to use the group command if somebody asks you to, if there is a specific command. But chown command can change the ownership and the group also. So now we have learned everything we need to know about this aspect of the Red Hat exam. Let me look at this. No, we'll take a look at this next week because this is going to get involved. A lot of questions will come. All right, ladies and gentlemen, we're going to do a bunch of labs this week. I hope you're going to enjoy them. They're already in the notes. A lot of the labs are already in the notes, but I'll also give you separate labs. And I hope you're comfortable, at least understanding. I appreciate your time. I want to thank you for learning Linux and changing your life. For Urdu students, we'll have a class on Monday, same time.